live. There we go. Not that people on the live stream care about the house. I see some people I know, but I also see lots of people I don't know. People are here, I think, for the first time. And if you are, welcome. My name is Tim. This is my co-organizer, Garden, and my co-organizer, Joe. And we're Santa Barbara JavaScript. And as you may have guessed from the name, we are a group of JavaScript enthusiasts. I don't believe in being dogmatic about languages. There's a ton of them out there. We just happen to like JavaScript. If there was one perfect language, we'd all be using less. So we meet once a month to talk about JavaScript. We'd love to have some other things to do as a group. If there's things you'd like to see us do, let us know, and we'll talk about it, get on the calendar. We are looking for some people to join the team. We're looking specifically for a speaker chair. It takes a lot. It may not seem like it, but it takes a lot to run one of these things. I have a full-time job, and I've got 2 kids, and I'm also vice president of the local dive club, and I have a wife. And so, it's not just getting up here once a month and introducing these things and sometimes talking at them. It's also, meeting with our hosts and sponsors and getting people to speak at these things. It takes a lot of effort. So if anyone is kind of outgoing and social and is interested in curating speakers for the group, see one of us and let us know. We desperately need your help. Now, we'd also really like to get somebody to help Garden with the AV. That's not a knock on Garden. We're used to do it all. But like last time I was speaking, and so there wasn't anyone to help in troubleshooting. We didn't realize until halfway through the talk that there was no audio in the live stream. Just kind of disappointing. Because I really wanted to use that recording to convince the people at Fluent to push my talk over the edge, but also because there were people tuned in. So if any of those things interests you, please let us know. The other thing that I'm really interested in is getting a logo for the group. Now, if any of you are graphically inclined or a designer, this sounds really cliche, we can't afford to pay you. We rely on the generosity of our sponsors for hosting and food, and I pay our meetup dues out of my own pocket. What we can do, though, is we can offer you a sponsorship slot. We can promote you on our meetup site, and we can promote you in front of events. And I know it's a cliche thing, you'll get exposure. But it's really all we can offer. If anyone's creative and would like to do a logo for us, we would really appreciate it. And lastly, and most important, I want to thank our sponsors. First and foremost, K-Junction. It's Mia back there. Who's hosting us tonight. So they're one of our regular hosts, and they also provide food and drinks, and we're very grateful for that. We also have Agilicis, which is my employer. They don't host us anymore because the group's gotten a little bit too big for the space that we have there, but they do provide pizza when we go to our work zones, which is our other sponsor. Next up is Work Zones downtown. We're there for the next 3 events after this one. And those guys have been a great host for us. They're a co-working space. If you're interested in checking out their product, let me know that we the guest pass. And then lastly, we have a partnership with O'Reilly Media. And through that, we get discounts on books and videos and conference passes. And if we use the conference discount 3 times, I get a free conference pass. My employer sent me, so I will raffle it up or something like that. Beyond that, we don't have anything yet for the next few meetups. I've got a few people who have kind of raised their hands that they were willing to do a talk. We might have something for September. I know Joe is talking about doing something.
I've got 2 in my ear.
Yeah? Can you do something for August?
Yeah.
Great, we've got to talk for August. Joe's going to talk for August. That'll be at Work Zones. Like I said, I might have somebody for September. But beyond that, the calendar is open. So if anyone in this room has something about JavaScript they'd like to talk about, you don't have to be an expert. One of the best ways to learn something is to teach it. A couple of years ago, I did a 3-part series on ES 2015 because I was interested in learning it. And the best way to learn something is to teach it. And lo and behold, I learned a lot about this stack. Anything related to JavaScript is fair game. And if anyone wants to raise their hand and be a speaker chair, that'd be even better because then you can talk to that person instead of talking to you. Anyway, that's enough housekeeping stuff. Welcome, we're glad you're here, and I'm going to hand it over to Jesse to talk to us about Docker and JavaScript.
Thank you.
So thanks for coming. I am absolutely one of those people that don't know a whole lot about JavaScript, but I know a lot about Docker. So I decided to pair the 2 up and kind of intro you guys potentially into building a JavaScript environment with Docker. Just so that's not misleading up front, what it really is the scenario later on is being like a new employee and not having anything with JavaScript installed, but then working on a JavaScript project via Docker. So we'll walk through that. So just a quick intro, my name is Jesse. I'm a cloud operations engineer over at Invoca. I'm recently a Docker contributor, which is always fun to have the contributor badge. And I'm the community leader and meetup organizer here in Santa Barbara. So I agree, meetups are really hard to organize, so please help everyone out. And yeah, come to ours. So the agenda, short and sweet, we're gonna walk through just kind of the basics, what is Docker and why I strongly think you should use it. And then just getting started with an existing project. So we have a repository at work that Garvin does a lot of work on, and he basically said, like, see what you can do with this. So that's what we're gonna walk through. So what is Docker and why should you use it? So raise your hand, who's using Docker now? That's about what I expected, cool. This hopefully will be helpful then. So what is Docker? So first and foremost, it is, quote, the world's leading software container platform. So something to keep in mind as you approach Docker as a new user and things like that is Docker is actually nothing new. Containers have been in the Linux kernel for years. Docker is just putting like a conversational API around it. So you can easily do all the stuff that goes into creating a container, but you can create containers with a bunch of CLI commands or like 100 lines of Go, for example. It's all built into the kernel. So a couple examples, developers use Docker to eliminate the whole works on my machine problem, which this talk will hopefully illustrate a little bit of. Operators, people like me on the ops team, use Docker to run and manage apps side by side in isolated containers. It's really about compute density. So if you think about a VM, the first kind of problem that comes up is like port management, right? If you want to try and run a bunch of different applications all on one machine, that gets really messy. And imagine then if one was Go, and one was Ruby, and one was JavaScript, and one was Python, it gets really, really messy with system dependencies and stuff like that. So you can kind of think of a container going forward as like an artifact. So everything needed for that application is within it. So operators love that kind of stuff. And then I crossed out enterprises because I stole this from Docker's website, and I really don't like prefacing this one with enterprises, but Docker essentially, people are using Docker to build agile software pipelines, which hopefully this will potentially illustrate a little bit too in this talk. But ultimately, it's really helpful for faster deployments. There's a lot of security features that can come with this. And what they're recently branching into is getting Windows and especially Azure to the point where you can run Linux containers on Windows machines. And we're getting to the point where we can run Windows containers on Linux machines, and it's all very confusing now. So hopefully they'll just all be one and the same later. So what is a container is probably the next question, which, like I just kind of mentioned, is everything required to make a piece of software run is packaged into an isolated container. So this is the obvious stuff, like packages.json is in there and everything's npm installed, but there's certain packages that require system level libraries, for example, and those are in the container as well. Unlike VMs, the biggest thing to kind of remember here is that this is not another virtualization play. This is not like VMware or VirtualBox. It's not another VM because we're not bundling the OS. And so only the libraries and the settings required to make the software work are needed. So this little illustration, for example, imagine a Linux box where you have the kernel kind of at the bottom, and you may have these 3 containers on top of it that have what's necessary to run those things. So a container might include a Debian base package, but then have Java layer on top of it and Tomcat application on top of that. But then over to the right, you might just have Alpine and a static binary. So like a Go compiled binary or something like that. But they're all just leveraging the kernel rather than virtualizing the OS. Feel free to ask questions too as we go. So if you compare the two, this kind of illustration hopefully helps a little bit. But on the right, you've got a VM where you've got the infrastructure and the hypervisor, and then as many guest OSs as number of VMs, right? Which then means you have to duplicate the guest OS, even if it's all the same. Whereas with containers, you just leverage the host OS to do all of the kernel communication and to actually create these containers and things like that. But you have Docker leveraging, or sorry, you have Docker on top of that doing the coordination so that you can talk to the kernel to create all these kernels, or the kernel to create all these containers. But then you have these containers on top that have whatever bins and libs and individual applications without the guest OS. So that helps too in terms of size, right? So we're not spinning up a guest OS inside of the VM that also has to create a virtualized hard drive. So I don't need like 20 gigs of space just to launch an Ubuntu container. And then the next obvious thing is it helps with startup. So I can spin up an Ubuntu container in like 2 seconds, whereas OS running Ubuntu probably takes 60, maybe 30. So iteration time and things like that are huge for the dev workflow, especially. Cool. So just some base vocabulary here, potentially an image to help. So like we mentioned, Docker is the container platform. A container is a runtime instance of an image. And an image is essentially an ordered collection of root file system changes, which hopefully that'll make a little bit more sense as we go over what a Docker file is. But the idea here is to end up with a hopefully immutable artifact. So when I run that container, nothing inside the state of that container should change. It should just be running my application. And then the Docker file itself, which is essentially just a text document of those instructions to create that layered file system. So maybe I'm going to make a directory, and then I'm going to copy some code into it, and then I'm going to install a package, something like that. Is that all? Any questions around that?
I think you just said they're going to make a directory that's changing the file system.
Correct.
Right? So does it have sort of like a mirror, like a parts of the file system that were changed, it sort of creates some little, you know, like the original file system remains unchanged, basically.
Yep.
So as soon as you shut the document, as soon as you shut the container down,
Yeah, so that's
it's a change list that kind of gets applied to the starting point.
Correct. Yeah, so that's actually a really good question. So hopefully this image over here can kind of help with that. So you can imagine the dark blue piece is your container, and a Docker file is going to create those layers. So maybe you start with a Debian-based image, and then you add Emacs or Vim or something, and then maybe you add Apache. That's the image, so that's immutable. When you run an image, you now have a container, and what happens is the topmost layer is a copy on read or copy on write. Yeah. So yeah, whatever changes you do make inside the container, when that container dies, those changes are gone. Unless there's something we'll cover too where you can volume those changes out to the host OS, and then you'd be able to repick them back up. That's it. Good question. Cool. So that was Docker 101. Questions on any of that? All right. So let's get started with kind of the scenario here. So I'm really big on that whole like works on my machine thing being batshit crazy and getting away from that as much as possible. So I actually think like new employees onboarding is a really good version of that, right? So you got a new employee starting tomorrow to work on your code. And I say your code because hopefully people can resonate with this, where it's like, yeah, I've set it up, and maybe I have like some script that like tweaks that thing really nice, and like I only have to enter one command to do that, and like I'm fine. But like introducing someone else to your project is always a whirlwind. So basically the objective here is to get up and running with existing code as fast as possible. And this list looks pretty good, right? So you're gonna git clone the repository, and then immediately you're gonna get into like, all right, let's npm install, grunt build, and grunt test. Does anybody know what the immediate problem here is? So new employee, new laptop. What's the problem with like the second step? Yeah.
They don't have NPMs.
Yeah, exactly. Or like in other tech, like the system version of Python or the system version of Ruby, and then those step on each other, and it's a mess. So that's what I'm going to try and defeat here. So there's no right answer to this, but looking at GitHub, what do we know about our code base? What do you guys think?
Say it's JavaScript.
Okay, JavaScript, it's good.
You're just doing that.
Yep. Cool, that's definitely enough to get us started. So what we're basically going to do is express the environment into that Docker file we talked about. So the objective here is to go build a Docker image that anybody can use. And to build that image, there's a series of commands, right? At least the npm install and the grunt build and things like that. So what we want to do is express that environment into a repeatable Docker file. So the first observation, it's JavaScript. So Docker lets you layer from things that were already built, so which is really nice. It's like building blocks on top of building blocks. So it turns out they maintain an entire library of a lot of the basics: Node, Python, Go, MySQL, whatever. So instead of starting every time from some Linux-based image and then installing Node, the one of 1,000 ways that you can just start with their version of Node. And then the colon syntax here is that you can tag images. So this is super nice for development because when Garvin goes, let's say, to upgrade this repository to the latest version of JavaScript, he can just change that tag and give it a test on a whole new version of JavaScript. So that tagging system lets you version between the images that have been pushed. So, okay, it's JavaScript, done. The code needs to go somewhere. So we're going to run, and then we're just going to create a directory in any arbitrary place that we're going to use throughout this file, so user source app. And then the work dir just says, hey, after this point, all future commands are going to be executed in that directory. So it's basically CDing into it. So work dir, user source app. The code relies on third-party libraries, which somebody noticed. So we're going to copy package.json and gruntfile.js to the current working directory from the repository. And then we're going to run npm setup, npm install, and npm cache clean. Just so there's less stuff on the file system, we run cache clean.
Sorry, is this running, you said copying the package.json, that's coming from the source, like coming from the GitHub source that you downloaded? Or?
Yeah, so at this point, we git clone the repository, and we're sitting in the repository like on my laptop. And then that repository now has a Docker file in it that we're writing. Okay. So when I run the build, it has the context of where you're running it from, so it knows how to copy things into it. Let's see. Assumes that built artifacts are reachable. So that's basically the grunt build. Right before the grunt build, what we're doing, it's weird syntax. You can write it better, but this is actually what's standard. Essentially, it's saying we're copying everything from outside the container into the working directory. So it's just copy dot dot. I don't like it, but it's whatever. And then run grunt build, which is the code assumes that there's some artifacts and stuff. And then the final command in pretty much every Docker file is either entry point or command. And it's essentially just, hey, when I start this container, what am I going to run? So we're going to run grunt dev for this one. So basically, when this container comes up, we're going to have grunt running a web server and serving an index .html for us to hit. Does that all make sense?
Why is it an array? Like, why isn't it just like a string like grunt space dev?
Good question. So you can do either. I forget the totally technical answer. I think if it's not an array, you're essentially executing bash with a command.
Okay.
So you're executing a shell.
Yeah.
This is preferred because in the Docker world, what you want is your process to be PID1.
Yeah.
So this is just straight up executing the command rather than putting in a bash shell.
Got it.
So question,
Yep.
how are different kernels handled in that from command?
So again, we're not virtualizing the OS here. What essentially that is, so yeah, somewhere in the node Docker file, it may be coming from like a Debian file system or Alpine or something like that. So all you have is the file system of it. So you would have like /mount and /var log and things like that.
So we have to hope that node 611 is compatible with whatever kernel I'm running on my machine. It doesn't try and find the 611 that matched my kernel.
You have something to add?
As long as you have a recent enough kernel to run Docker, it doesn't matter what distribution you run within Docker.
Yep.
Okay. Cool.
The only incompatibility I've seen is trying to run a lot of the standard images on like an ARM processor, for example. But that's just a different texture entirely.
Okay, so most kernels are cross-compatible.
Cool.
Yep.
If you were also trying to access like fiber channel storage and you didn't have the kernel correct in the module, you'd run into issues as well.
Right. Yeah, and trust me, we're barely scratching the surface. There's all sorts of other expertise around storage drivers and network drivers and things like that. So yeah, there's a lot more that comes with compatibility.
Well, remember one of Linus's rules, we do not break user space.
Yeah.
Said whenever someone does a Linux kernel, very colorfully.
Cool, so now that we have the environment kind of described in as plain of English as I think we can come up with into the Docker file, what we essentially want to do is build that image from a Docker file, right? So there's a bunch of other options that go with this command. I pulled out the one we're going to use. So at that point, you just want to do Docker build. We're going to name it with -t. And the naming schema for Docker is usually, so like they point out here, name : tag. The name is usually your organization. So similar to GitHub, where you might do like Invoca / repository name, this would be your organization on Docker Hub / your image name, which is essentially your repository. So there's GitHub for code, there's Docker Hub for Docker images that you can push to remotely. But you can arbitrarily tag it whatever you want if you're not going to host your own registry. You can also host your own registry. Yep. So basically, well, I can start demoing at that point. So there's our Docker file that we had come up with. Then I have one additional tag there of just label maintainer, which is just like some metadata. So from that point, we're going to, like I said, Docker build, and we're going to call it Invoca ops / pnappy.js. And then this kind of goes to your statement that it knows what context you're in, so you always have to give it the context, which in this case is just dot, like you're going to start from here. You can always execute, let's say your Docker file is like one level down, you would give it that context. And so that's going to build. This is super fast because it's pretty much cached. There's this one layer that is apparently not cached, but ultimately all it's doing is running through the instructions we gave it. So it's going to copy in some code, it's going to run the npm install, things like that. npm install is incredibly noisy and is outputting to standard error. I don't know if anybody has ever realized that. It's really ugly in build servers and stuff. It's like, oh wow, my build must be crapping out. No, it's fine. They just decided to output to standard error. Cool. So there's an example where you can kind of see like step 7 of 9, we're going to copy the code, and that's essentially just the stuff we'd given it before, right? Step 7 of 8, or 8 of 9, it's going to run grunt build, and there's the output from that. And then ultimately, you can see at the end, successfully tagged Invoca ops pnappy.js latest. So if you don't apply a tag, it's going to just apply the latest tag. And equally, when you pull an image that someone else has built, for example, if you don't apply a tag, it'll apply latest and pull the latest tag. Careful of that though, the latest tagged image isn't always the latest image, because if they don't tag it latest, it could have been from 10 months ago.
One question. So if I was developing locally and I just did this and I wanted to like check out a new branch, does it have to run through all this to create a new branch?
It depends, and I'll kind of show you the dev version of all this.
Okay. Cool.
The short answer is you'd want to rebuild if your packages.json changed, for example.
Okay.
Because it has to build that into the container.
Cool.
Good question. So we have an image, and I can prove that with Docker image ls. I have a bunch of other images, but you can see the most recently built ones up at the top. pnappy.js, it's latest, and then there's some SHAs and the size. Turns out Node with some code put in it and some packages is 780 megs. Fun fact. Cool, so now we want to run that. Again, there's a bunch more options here. This is the more powerful of the commands, but I pulled out the ones we're going to use. So you would do Docker run. You might give that container a name. If you don't, they're going to pull from some random bag of vocabulary that they have, and it comes out with some really funny names. So you might give that a try. But you realistically want to name your container something. I might have an example of one that's not. Oh no, that one is named. But anyways, so you would name your container. If it has ports to publish, you want to publish those ports. So let's say inside the container, grunt dev is going to open up 8888. You need that to be accessible outside of the container. So you need to publish that port to whatever you want. So you can publish it to 8888 if you don't have anything else running. I can publish it to 1234, whatever. So yeah, that's going to have to happen. And then I'm also going to tack on the RM, which just basically cleans up the container when I'm done. You don't have to do this, but what you'll end up with is I'll do Docker run, I'll get out of that container. That container is still there, it's just stopped. So I like cleaning up entirely after myself so I can run it again and not have these old containers hanging around. Cool, so we're gonna do that. And that's the Docker run statement, if that kind of explains it a little bit better. So we're gonna Docker run, name pnappy.js, we're gonna open up 8888 and 8889. And then when we cancel out of it later on, I'm going to remove it. And then the thing I'm going to run is that Invoca ops pnappy.js image that we ran. So let me do that. And 888, 888. Cannot be, nope. Cool, so that's running. There's another flag that we could have thrown on here of -D, which is detached, which would have given me my prompt back and the container would just be running in the background. Because I didn't do that, I'm attached to the container, which means I'll get all of the standard out. And when I hit Control-C, the container will die, things like that. Yeah, it actually, so it'll send the proper like sig term, and if the application that's running within it doesn't understand that, it'll send a sig kill 10 seconds later. So yeah, you got to be a little bit more conscious of potentially how you're writing applications. If you don't care, then you don't care. But if you want your application to purposely interpret the signals and close down nicely and things like that, then you have that ability.
Yeah, think about it, it's accessing databases and stuff like that.
Right, exactly. Yep. What was I going to do? Yeah, so now I have an application running. So to kind of prove to being in ops, I don't normally have, why isn't this giving me my screen back? Hello. Yeah. Great. So I don't normally have Ruby and all the other stuff that a lot of the devs have installed, and just to kind of display that, like these things are not on my path, and I am running the application, but it's just running in a container, which you can see there now. So yeah, that, like I could stop the talk there. Like that's a working JavaScript environment that I didn't have 5 minutes ago, right? So that's the first punchline. Cool. So what gets a little bit more powerful, especially for dev, is another tool that Docker has called Docker Compose, which takes that not friendly command that I just ran and essentially turns it into Docker Compose up. So the Docker Compose.yaml file is another file that you would source control. And in this case, there's some new versions of Docker Compose. With this one, we're just going to use version 2. But what Docker Compose wants to do is orchestrate multiple containers. So you just mentioned like database, for example. So you could run MySQL in a database and your Node.js application, or sorry, MySQL in a container and your Node.js application in another container. And this would orchestrate the two so that they came up together. And then Docker's actually, especially when you use Compose, it's going to enable service discovery because it's going to put those two containers on a network all by themselves. And your Node.js would be able to talk to MySQL simply by calling MySQL as the host name. Yeah, in this case, we just have the one container, but it's still, like I said, kind of takes that awful Docker run statement and turns it into Docker Compose up. And then we're going to do another trick in a second. But hopefully you can kind of see that this does the same thing that we previously went through. So it's just going to define the pnappy.js service. It's giving the build context that we previously gave. It's telling it an image name that we're going to tag it as when we do that build, and it's also serving the other purpose of, hey, I'm going to run some image, and that's the name of it. And then we're going to open those ports that we had defined previously. So
your MySQL would also be under services with pnappy.
Say it again?
Your second container for MySQL will be under services as well.
Correct. Yeah. So you define all your different services, and then they would have similar tags of like what ports you're going to expose. So it might be 306, things like that.
Are they all available to each other if you have like, let's say 10, or can you say, I only want this one to be able to talk to?
Good question. So yeah, especially the newer versions, you potentially bump the version from 2 to 3 or 3 dot something because it kind of changed the way those keys work. But yeah, you can define networks and then use those networks. Mm-hmm. So often an example they'll have is maybe you've got an application with like, so a database and then like a Node.js front end and a Python backend or something. And you can have a backend network and a front end network. And the Python application might be on front end and backend so that front end can talk to it. But then the database and the Python backend will only be on backend. So the front end has absolutely no chance of talking to the database.
Mm-hmm. Cool.
Yeah. Okay, so I just need to kill this guy because I lost that terminal earlier.
So I'm confused about what you just said. Is that all happening in one container, or are you?
No, different containers.
3 containers.
Yeah.
For each, okay.
Yep, different containers. So again, back to the concept that Docker wants a process to be running in a container, period. So you wouldn't have a container running with MySQL and Node.js. You would just have MySQL and just have Node.js, and they would talk over the network. Cool, so make sure I don't have that running. So I already have my Docker Compose that we just talked about, and there's some other stuff happening here that we won't do yet. But now I've got the Docker Compose up, which way nicer and way easier to remember than that run statement. But you can see the same thing's happening. So now I've got localhost 8888, and that's running again. So now we've shortened what needs to be typed. And I forget who asked it, but back to basically, how should this work in dev? Do I need to rebuild every time I go to a new branch, things like that? So what we want to do in this case, especially for dev, is add volume maps for live updating code inside the container. So essentially, you've already built the container, you've already moved code into it, but on run, we're going to inject a live directory. So if you change code, it would change inside the container and things like that. So in this case, it's a little messy, and again, I guess being new to JavaScript and stuff like that, but what happens in the build, right, you move all your code in, you npm install, and you have your node modules in there. With some other things like Ruby, where the gems would install to a central location outside of the working directory, you can just volume in the whole repository, which is really nice. In this case, we have to volume in around node modules so that we don't overwrite it. But it works. It's 4 lines of YAML, not a big deal. So basically what we're taking is the 4 directories from the repository that would have potential code changes, and we're voluming them in to where they were copied in. Does that kind of make sense?
Yeah, it allows it to be mutable, right? Like
Yeah. This is absolutely not something you would do in push to production, because the whole point is having those immutable artifacts. But in dev, this is gold.
It's mapping or it's copying or?
It is actually mapping directly in. So this, like if you're familiar with Vagrant, yeah, it's literally mapping directly in. So much so that all of the volume, like the storage plugins and things like that that are a whole other part of Docker, it bypasses all of that. It is literally writing a direct link. So now if we Docker Compose up, being that I've uncommented those volumes, like if we were to go here, and the title is solution.js example page, and if I were to go to here, SPJS meetup, refresh, SPJS meetup. So hopefully you guys can kind of see that, like the power of this, where it's like you built your image, switch branches, things like that, it all kind of just works, but you've got this running in an isolated environment. So let's say you wanted to take that branch and now test it against the latest version of JS. You would just update the tag that the Docker image is building on. So it'd be as simple as like coming in here and then changing that and rebuilding and keep going. So you don't have to install a new version, things like that. Yeah. Any questions around any of that?
So just to be clear, like how you said you wouldn't do that in prod, but it's okay to have like a volumized image in production for like Nginx error logs or something like that, right? Like if you wanted something that you do want access to, if you had to SSH in and check stuff out.
Yep. Yeah. So it's a gray area. It's one of those areas that I wish people talked about a little bit more. Nobody's talking about it because nobody's standardized around it. But there's a couple different things you could do there. So one pattern with containers is that they assume or they want all output from the application to be going to standard out. That's accomplishing also the fact that you're not mutating the file system. You're not writing a log file inside the container. Because of that kind of write layer, the performance is really bad if you're mutating the index. You're just essentially bloating the size of what Docker has to keep in mind. But if you're just doing it standard out, it gets flushed every so often. So because of that, you can run, there's a pattern where you run like a sidecar container. And that container's job is to just sit on the machine and basically consume all standard out from all containers and then ship it somewhere. So like an Elk stack or something like that. Or yeah, another really much easier and probably a first step for a lot of people is to just straight up volume out the logs for the respective containers. And then go with whatever they're using to ship logs potentially, or log rotate them or whatever. So yeah, you can definitely do that in production. Cool. So just kind of recap and drive this point home. Hopefully the objective was to get running code as fast as possible. So now the process here is to git clone and type docker compose run pnappy.js grunt test. So faster, right? And just to kind of show that off. So with docker compose, the kind of standard would be docker compose up. And that's just going to run exactly what you told it to between the Docker file and the Docker compose file. But you can also tack on, and this is the same for run, where you can tack on a command to the end of the command that would overwrite what's already been defined. So in this case, we had the Docker file that described grunt dev as the command. So if I type nothing, it's going to run grunt dev. But if I type a command to give it, it's going to overwrite that and run that one. So I could do docker compose run pnappy.js, which is just the service name. So if I had another service here and it was all described with the ports and things like that, I could target what service to run potentially as well. So if I just wanted to run MySQL, I could open that up with all the right ports and things like that and volumes. So I'm just going to run pnappy.js, but I'm going to give it that grunt test. Yeah, I'm going to give it that command to run. Instead of grunt dev, I'm going to run grunt test. So again, new employee, I've git cloned a repository, I've installed Docker for Mac, and without even building the image, if I were to run docker compose, it would say, oh, you don't have that image, or oh, that image doesn't exist up on a repository, but you told me how to build it. Let me build it, and then when I'm done building it, I'm going to run your tests, and then you're done, right? You're set up, quote unquote, as per the company's instructions. So yeah. There's that.
So is that just overwriting that command line at the end, or did you have to tell it what grunt test was? Does that make sense?
So it's overriding the command that was defined in the Docker file.
Okay.
And then, yeah, assuming grunt is on your path and things like that, then yeah.
Okay.
Yep. So kind of some things to take away from this, and maybe some things we implicitly talked about but wasn't a dot on the slide. So obviously Docker has benefits for DevOps. And actually this was an interesting use case where this one is set up to go for CI now. So grunt dev is pretty much just for development here, but pnappy.js isn't a server application. So it's just JS that goes on a page for us. So dev, for example, reduces the setup time required, which we showed. Ops standardizes artifact deployment down to just simple CLI commands. And then CI, I'm able to run new code tests in ephemeral standardized environments. So this is really important. This is one I've been chasing recently where I'm setting up a new Jenkins cluster. And with everything I'm going to do with Docker, I'm not installing any language on the build servers. I'm not installing Ruby. I'm not installing JavaScript. I'm installing everything because I could just use containers. And they're ephemeral, so I know the build's going to be the same every single time. Wins can be realized in as little as time as it takes to present at a meetup. I did all this work as I built it, so maybe 2 hours to build all the slides. And you don't need to be, quote, doing microservices to use Docker. This was something I was actually stuck on, I think, for a while, where these two definitely come paired together in terms of literature online, where if you read about microservices, somebody's going to talk about Docker. If you talk about Docker, not many people are talking about monoliths. But really, you can take a monolith and put it in Docker all day long if you want. It's going to be a big container, but who cares? And they do now have a very expensive paid service to put monoliths inside containers, and they'll help you guys. So yeah, I think that's important to realize. Again, like you may be able to realize a win by just putting your application in Docker for development, or just doing it for CI or things like that. But the wins you'll see from those things will likely push you to keep going, which I think is cool. And it definitely works on now every machine, which is hopefully seen as powerful as well. So just a few quick housekeeping things for myself, I guess. So yeah, Docker Santa Barbara is a thing. There's a few people here who have seen it meet up, so thanks for coming. And if you haven't, feel free to come by. If nothing else, we get a lot of free swag. I can wear a Docker shirt every day of the week. That's fine by me. But yeah, we're getting new swag soon, so please come by and meet up. There's a Docker community Slack that they like at here, 6,000 people at a time, so that's fun. But it's cool, there's pretty much a channel for everything. There's a channel devoted to networking and storage and Docker for Mac and Docker for AWS and whatever. So it's an incredible place to get help. More than you'd imagine of their engineers are sitting in that Slack. So it's a really, really good resource. If nothing else, I've identified like bugs and then like not filed them. I just like shout it out in the channel and they're like, oh yeah, we're fixing that. So that's really great. And then I think you guys have a Slack, but we had started one as well just for like Santa Barbara in general, technical people. You can get an invite for that just at sdtechcoop.com. So feel free to join us. We could definitely use some people actually sharing problems that they have on that. And that's it. Yeah.
You're using a Mac.
Yeah.
Are you using Docker Machine?
No. So that is, if you find literature on that, it's outdated. I think there's still some uses for Docker Machine because you can launch VMs and stuff in the cloud with it, but it is a little outdated. So what Docker Machine wanted to do was basically wrap around VirtualBox and create a VM to run Docker inside of on your laptop.
The kernel doesn't do well with.
Right, so they acquired Unikernel or some company to basically go rewrite some wrappers around this and Windows and Linux and everything else. So now it's just native Docker for Macs, which you can see up here. And yeah, it's 1,000 times better.
Yeah, they use the X5 virtualizer in Mac OS, right?
Yeah.
Yeah, so there's some virtualization going on.
There still is.
It's still a VM, it's just very, very, it's only one VM, it's not a VM for each.
Correct. Yeah. Docker Machine had all sorts of like, oh, I lost the connection to my VM. Really shitty experience. But yeah.
Have you been experiencing the bugs when you close the lid on the laptop, the time gets out of sync and you have to restart it?
It's actually a pretty interesting thread to follow on GitHub if you want. Yeah, so who knew time was a hard problem? Yeah, the VM loses track of what time it is. The biggest place you'll see it is if you're trying to do any kind of work with like AWS through your containers, because they're really, really strict about their API call validation.
Yeah.
So I think that's where most people are running into it.
That's where I've seen it.
Yep. Yeah.
And how do you manage, like, if you have like a fleet of people using this and you have like per fleet or something and you need to get everybody updated, how do you do that? So
it's an interesting topic, and if you think back to the core concepts here, it actually makes all of that 100 times easier. So you got your machine, and that's not running any code, it's running containers. So if your container has a vulnerability, you rebuild that once, push it to the repository, and then run a deploy where all of your images that are running off, all of your containers that are running off that image now get updated. So if you had some container that had a vulnerability in it, and let's say there was 100 containers running in your...
Oh, so the containers are pulling back to see if there's updates and
They're not pulling back, that is a whole kind of separate piece of just what you choose to deploy with. Kind of gets into the realm of orchestration, which there's Docker Swarm and Kubernetes and Mesos and a whole other side of things. But essentially you would maybe make an API call to say, hey, deploy, and the deployed version should be 1.1. And so if 1.0 had the Heartbleed, for example, 1.1 didn't, it would then roll through your entire fleet, update the image, and now your vulnerability is gone.
But in that scenario, you're talking about servers as opposed to like devs who are using Docker on their work laptop.
Kind of the same thing though, right? So let's say this repository, if there was some kind of vulnerability in that, all it takes is one dev to fix it, commit it, build the image, and then everybody just has to pull the image.
Okay, so it'd be,
yeah,
that would be different. That'd be, since they're machines, and there's a certain
But it is abstracted one level, right? Because I can go in and I can update the image and know that the next time somebody runs that image, they're going to be running my update versus sending a company-wide email and being like, hey, if you guys could all run this script, that'd be great. You can kind of force it on people. So,
and is that actually, you guys do it at Invoca, do all the devs, do they all work out of containers?
Soon. The application Invoca itself has some challenges just because there's an entire telephony stack, which gets a little hard to do with Docker, and there's some networking restrictions that we face where a lot of the software needs a one-to-one NAT with the host. And Docker wants to kind of virtualize the whole networking layer and things like that, so it gets really confusing. But short answer, yes, we at one point did spin up like 20 containers on a laptop and had the entire stack. So it's doable. It's just a little difficult to maintain. We ran into the issue where you may have Docker Compose all written up, and that was kind of like our MVP, where we had the 20-something containers. But then we needed an orchestrator when we move into production, and we chose Kubernetes. And defining what all of this looks like in Kubernetes is a whole nother set of YAML. So as we made changes to Kubernetes, we didn't go back and make changes to Docker Compose to keep them synced up. So now we've got like the Docker Compose that's super outdated and just broken. But instead what we do, and this is a whole nother talk, but we have an entire Kubernetes cluster that manages all of these containers that we just let people spin up entire stacks of the platform. So somebody could have a branch of code that they want to test out, and they would spin up an entire cluster of the platform in Kubernetes. So that lets us do like hourly regression testing of the entire suite of integration tests and things like that, and we run multiple clusters in parallel. But now we have the leverage of that density packing that I mentioned, where you just have all your problem is you need a cluster with as much compute as possible, and then you're packing containers onto it. Whereas when we used to spin up a cluster, it'd be that many VMs that we would need to go provision. So we've cut that size of QA clusters down by like 75% in terms of actual machines on AWS.
Yeah, and like instead of having a couple machines up on AWS, I spun up a Kubernetes cluster today, for example, in like 10 minutes. I was working on my branch.
Yep.
It's been like super awesome for local development.
Yeah, I mean, the time is actually another good point that Garvin brings up. So previously spinning up a QA cluster of 20-something machines is that long, right? You have to spin up 20 VMs, provision them with Chef or whatever you're using, deploy code to them, etc. So that would take an hour, whereas he can spin up a cluster in 5 to 10 minutes. So yeah, and our biggest bottleneck there is the AWS API for creating load balancers and things like that. So yeah, any other questions? Cool, thanks for coming.
So just like it takes a lot of time and effort to put together these meetup groups, it takes a lot of time and effort to put together a presentation, and it takes guts to stand up in front of a group of people and give it. So let's give another hand for Jesse. Just appreciate it.
Yeah.
And you too could be standing where you're giving a talk to these kind of people.
Yeah.
It's a rush, it really is. And it's a great way, like I said, to learn and teaching. So that said, it looks like next month we're going to have Joe talking to us about, you got something about LDAP?
Well, it'll either be LDAP as an authentication front end to microservices, or it'll be working with Bitcoin and JavaScript.
Right, so one of those really cool topics will be on next month's agenda. We'll be at Work Zones, which is downtown. If you don't know, it's right across from the movie theater in Paseo de Cuervo. It's a great little space, and Genesis will provide the pizza, so we hope to see you there. Thanks, guys.